Mm-hmm.
So it's okay.
So for these factoring problems, if you run into a factor that can be solved using your unit circle, then you will solve it that way. If you run into a factor that is not on the unit circle, you will solve it that way. Okay? Does that make sense? All right. So the first problem we're going to do is 2 sine squared x minus 3 sine x plus 1. And for this, we are going to find all solutions. So 2 sine squared x minus 3 sine x plus 1. And sine squared x is just a fancy way of saying that the sine x itself is being squared. We just are being lazy and we don't want to write the extra set of parentheses. So the first thing I'm going to do is I'm just going to rewrite this so that I understand what that squared means. So it's 2, and the sine x is being multiplied by itself. Okay, so 2 sine x is being squared minus 3 sine x plus 1. All right. Now, off to the side, I'm going to kind of translate this from trig into like a normal problem so that you guys can see like how each of the steps would go. So this is kind of like if we were factoring the problem 2x squared minus 3x plus 1 equals 0. That's like basically what we're doing. So what type of factoring problem is that? It's almost a diamond. It's a slide divide because it has a 2 in the front. So I'm going to look for two numbers that multiply to 2 but add to negative 3. Multiply to 2 but add to negative 3. So what are the numbers?
Negative 2, negative 1.
Negative 2, negative 1. So that means that in my parentheses I have x minus 2 and x minus 1. But we're doing a trig problem. So what that actually means is that in my parentheses I have sine x minus 2 and sine x minus 1. In a slide divide problem, what would you do next?
Divide that number 2.
Yeah, the number that you slid, you would say, I need to divide by that. So the number we slid, we divide by. Okay? Then what would you do? Simplify. So 2 divided by 2 would be in parentheses, you'd have x minus 1. What would you do with the other one? Yeah, you would bottoms up. So that'd be 2x minus 1. So that means that here we have sine x minus 1, and we have 2 sine x minus 1. Okay? And how would we get solutions for our factors once we made it that far? Yeah, so we would say for this one, x equals 1. What would we say for the other one? X equals positive 1 divided by 2. Positive 1/2. So here we have sine x equals 1 and sine x equals 1/2. Okay? Now this problem is done. Our problem is not done because we didn't get the x alone. We got sine of x alone. So at this point, this is where we look at our unit circle. Are 1 and 1/2 on the unit circle?
Yeah.
Yes. Okay, so that means we can get our solutions from the unit circle. So what location has a y-coordinate of 1? Pi halves. So we're going to say x equals pi halves. And since I'm finding all solutions, I'm going to say plus 2 pi k. And then where on the unit circle is there a y-coordinate of positive 1/2? Pi 6 and? Okay, so I've got pi 6 and 5 pi 6, and I do plus 2 pi k for both of those. And that's my answer. Do you see how it's taking what we did yesterday and it's adding some more to it? Because the only difference between today and yesterday is now we're factoring. We're factoring and then we get some answers. Okay.
So you have to have 3. You can't just do positives plus 2. You have to have the 5.
You have to have all of them. Okay. All right, here's the next one.
Wait, do we have to have all of them on this thing too? On these ones?
The plus 2 pi k.
Like multiple.
You're finding whatever the instructions say, that's what I want you to find. So it could be find all answers between 0 and 2 pi, in which case you'll have 2. For factoring, you could have more than 2, but for the first couple on the worksheet, you just have 2. If it says all solutions, that's when I want the plus 2 pi k. Okay. All right, so for the second example, we're going to do 6 cos squared x plus cos x minus 1 equals 0. And for this one, we are going to find solutions on 0 to 2 pi. So in the event that one of our solutions is in that spot, we can't use 0 as an answer, we would have to use 2 pi as the answer, okay, because that's the same spot. All right, so I'm going to go ahead and rewrite the problem because cos squared written like that can be kind of confusing. So 6 times cos of x squared plus cos x minus 1 equals 0. And I'm going to write it in like less triggy type of math. Okay. Now, when you guys are doing this on your paper, I'm okay with you doing the math off to the side looking like this so that it can help you think through the problem. But if you don't show all the work in Trig as well, I will not give you credit for the problem. Do not only do the problem like this. You have to show me all of this work as well. Does that make sense? Okay. If you only want to do the trig work, if your brain is fine with that, then only do the trig work. Okay. All right. So what type of factoring problem is this? Slide divide. So we are looking for two numbers that multiply to -6, but add.
Oh, that's a -6.
Yeah, because 6 times -1.
Oh, word.
So multiply to -6, add to 1.
-3, 2.
It's 3 and -2, right? Because we want to add to a positive 1. Okay. So that gives us x plus 3, x minus 2. And over here we're going to say that's cos x plus 3, cos x minus 2. Right? And then what do we do? Divide by 6. So the number you slid, you're going to divide by. So the number we slid, we divide by. Okay. And then what do we do with all of those fractions? You simplify them if you can. So 3 over 6 is actually what? 1/2.
Sorry, how'd you have positive 1 when you guys calculated?
From right here.
Oh, okay. Oh,
Yeah,
yeah,
look
that
at
is
quad.
What did you? Today. Okay. So what do we do now that we've simplified the fractions? We bottoms up both of them. Okay? So it's going to be 2x plus 1, 3x minus 1. So this would be 2 cos x plus 1, 3 cos x minus 1.
Ms. Bryce, is that step really necessary?
Technically no, but if it just said factor, then yes. So for solving no, for factoring yes. I'm going to try to always show you something that's mathematically accurate, and this is mathematically accurate. Yeah. So from here, we want our solutions, and what are the solutions? Okay. So what Hector was referencing is you can see the solutions easier from right here before you bottoms up. The reason I was saying that you should bottoms up is because technically these factors are not right. If you FOILed that out, you would not get the original equation. So this is you writing the factors correctly, but yes, if you were just solving it, I could see that it's a little bit easier from right here. Yeah. So negative 1/2, positive 1/3. Same thing over here for cos x. Cos x equals negative 1/2. Cos x equals positive 1/3. All right, so is negative 1/2 on the unit circle? Yes. Okay, so we're going to look at the unit circle, and this is a cos problem, so we want to see where there's an angle measurement where cos, the x coordinate, is negative 1/2. Okay, so 2 pi thirds, and there's one more. Not 5. 4 pi thirds. Okay, and oh, we're just doing from 0 to 2 pi. Okay, so those are good for that one. Okay, and then what do we do about the 1/3? Is that on the unit circle? Nope, we use our calculator. So now I'm going to do cos inverse of 1/3, and there's my first answer. And then how do I find my second answer?
2 pi minus.
Store that as x.
Third.
And then I'm going to do 2 pi minus x. So the second answer is 5.052. Okay. I want to show you how to double check your answers on a calculator. All right, so we need to have this in here. I stored the first answer as x, so I'm going to go ahead and store this one as y. I'm going to write on my paper, I stored that one as x, I'm going to store this one as y. And so here's how you would plug these in to check and see if your answers were right. I'm going to look at this version of the equation because it's easier to type. This version of the equation, you have to like translate that squared in your head. Okay, and I want everyone to type this on their calculator. So here's what we're going to type. We're going to do 6 parentheses cos x, and we're actually going to type in x because we stored our first answer as the x value. So 6 cos, actually we have to put parentheses around that, parentheses cos x. Now your calculator adds an extra parenthesis and you did not have that on your paper. So we have to end parentheses to end the number that we plugged in, and then another end parentheses because the cos is being squared. Does everyone see that? So I want to hear it clicking because I hear everyone typing that in. And then I'm going to see plus cos x minus 1. Your guys' typing is not convincing. All right, so I know that I got the right answer when that equals 0. Does that make sense? Now I should be able, if you hit second to enter.
Do we have to minus? Do we have to put the parentheses before we minus the x? Because I didn't see that.
Oh, that shit.
You might have a typo somewhere. So check to see if you have a typo. So when you're done with that, if you hit second enter, it will get it back up on the screen again, and then you can go in and put y's in instead. And that one should give you 0 as well. And just so that you are not, I hope you're not thinking like, oh, it's just working because every number works. I'm going to go ahead and plug in a different number in here. I'll do 0.5. And you'll see that 0.5 does not work. So it doesn't make it equal 0 because 0.5 was not a solution. Okay, does that make sense? So that's the way, if you ever want to check your answer like on a test, that's how you could plug your answer back in just to make sure you got it right.
I still got it.
And they should be always equal 0?
Well, I was making it equal 0 because my original equation equaled 0. But if your original equation equaled 5, then it should equal 5. Okay. I'll come back and check yours in a little bit. Okay, we're going to do another example problem because I want us to do one with tangent as well. We actually have 2 more examples. All right, so we've got 3 tangent squared x plus 8 tangent x plus 5 equals 0. And this time we are going to find solutions from 0 to 2 pi. So solutions from 0 to 2 pi. You got it? Okay. So what should I do? Make it look a little bit nicer. Do you guys want to only do this one in trig, or do you want to keep writing off the algebra stuff on the side?
Nah, just keep it normal.
Only trig?
Yeah.
We can do it? Okay. So what type of factoring is this?
Slide.
Slide. Okay. So we are looking for two numbers that multiply to 15 and add to 8. Multiply to 15, add to 8, that's going to be 5 and 3. Okay. So what do I put in parentheses? Tan x You didn't even know I was waiting for you. Okay, so tan x plus 5 and tan x plus 3. And then what do we do? Divide by 3. So the number you slid over is the number you divide by. And the first fraction does not simplify. So what do we do with it?
5 tan x.
So we bottoms up. So it's 3 tan x
Word.
plus 5. Okay. And then the other one is
10 plus 1.
tan x plus 1. Okay. And so for the first parentheses, tan x equals negative 5/3. And the second tan x equals negative 1. Okay. Is negative 5/3 on the unit circle?
No.
No. So we need to go ahead and solve this one. Okay. So tan inverse of negative 5/3. Okay. I got a negative answer. Is that between 0 and 2 pi?
No, you add 2 pi.
I could add 2 pi. Now, how do I find all the answers for tan anyway? You just add pi to them. So if I add pi, that'll at least give me one of the answers. It's not coterminal with this, but it will give me a valid answer. Okay, so 2.111. And then if I add pi again, now I've added 2 pi total, so this answer is actually coterminal with that negative answer that I found. So x is 2.111 and 5.253. Okay. Does tan equal negative 1 on the unit circle?
Yeah.
Yes. Did you say you heard? You heard? I like it. All right, so where does the y divided by the x simplify to become a negative 1? Pi, not pi fourths, that's positive 1. 3 pi fourths, and then which one's like directly across from that?
7 pi 4.
Okay, so 3 pi fourths and 7 pi fourths, and we are done. Okay. All right, I want to show you one more factoring one where we are not doing a diamond problem. We're not doing slide divide. We're going to do GCF. Okay? So I'm going to put this away. Actually, I might do 2 problems because one is a very common one, and you'll be confused the first time you see it. We're going to do 2 more examples. I'm sorry, the last one's very quick. Okay, so this example is going to be 2 sine x cos x equals sine x, and we're going to look for answers on 0 to 2 pi. So I can tell that I have to factor to solve this one because it's got multiple sines and cosines. That's what tells me I have to factor it. Kind of like if you had an x and a y in a problem. Or if you had an x squared in a problem, you'd be like, oh, I got to factor that. I can't just get the variable by itself. So to factor, I need it to equal 0.
Minus the sign.
I'm going to minus the sign over. Now this term right here has a sine and a cosine. So I can't subtract this sign from that stuff. I have to just tack the negative sign on the end. So it's going to say 2 sine x cos x minus sine x. And that equals 0. Yes. All right. So this is kind of like if we had a problem like 2xy minus x equals 0. You guys see how those could be similar? Okay. So if you look at this problem, what's the GCF? X. If you look at this problem, what's the GCF? Sine x. So we're going to take out a GCF of sine x, and then we're going to write our leftovers. So if you take sine x out of the first term, what's left over? 2 and a cos x. If I divide out the sine x there, what do I have to leave behind as a placeholder? A 1. I divided out a sine, I still got to have a 1 there. Okay, because sine divided by sine is 1, like anything divided by itself would always become 1. Okay, can I solve those factors? Yes, I can, right? If no, they're not calculator problems. If I had, so this is the problem I have, right? That's the factoring we just did. So if this is the factoring, what would you guys tell me x equals? You'd say it equals 0. So sine x equals 0. Okay, and then what would you tell me about this one? Cos x equals 1/2. Yeah, positive 1 divided by 2. Yeah. Okay, so I'm looking on the unit circle to see where I have a y coordinate of 0. Okay, so I heard 0, I heard 2 pi, and I heard pi. Now let's look at our possibilities up here. What does this notation tell me?
0 to 2 pi.
0 to 2 pi, but what does it tell me about 0? It can't be 0, it has to be 2 pi. So I'm not going to put 0 and 2 pi. Which one do I get rid of? I get rid of the 0 because that was a parenthesis. 2 pi was a bracket. So these are the same spot, but 2 pi is the one I have to keep. Okay, so 2 pi and pi from that one. What about where cos x is 1/2? So we're looking for an x coordinate that is positive 1/2. 5/3 and 5 5/3. Okay. Does that make sense? Okay. One last example. I promise this is the last one. It's going to be quick. Sine x minus cos x equals 0. Sine x minus cos x equals 0. The reason we're doing this one is because it's a common problem. Like I've seen this over the years several times, and students never know what to do with it. They're always very confused. Because if you look at this, this is kind of like they're saying factor x minus y. Can you factor that? No. So here's what we're going to do. We're just going to add the cos to the other side. This is like the only time I'm going to tell you it's okay not to have it equal 0. And so basically, this question is saying, at what angle are the x coordinate and the y coordinate exactly the same? Pi fourths and... not 3 pi fourths, they're opposite signs there. 5 pi fourths. So here, x equals pi fourths because the x coordinate and the y coordinate are both root 2 over 2. They're the exact same. So sine of pi fourths is root 2 over 2. Cos of pi fourths is root 2 over 2. They're the same. Okay. The other place that they're the same is at 5 pi fourths, and that's because sine x is negative root 2 over 2 and cos x is negative root 2 over 2, so they're the same. Okay? Does that make sense how we did that? We were a little bit tricky, but okay. So if you see that problem, now you know how to the trick to solving it. All right.